Hello, this is Mr. Royks, and what we're going to do today is a podcast on stoichiometry. As we mentioned in class, stoichiometry is just really a fancy term for looking at the mole ratio or mole relationship within chemical equations. So the problem we're going to look at here is a reaction of magnesium nitrate with silver chloride produces magnesium chloride and silver nitrate. We'll be determining how many moles of silver nitrate are formed from 1.5 moles of silver chloride. Then we will determine how many grams of silver nitrate are formed from 0.5 moles of silver chloride. And lastly, how many grams of silver nitrate are formed from 2.25 grams of silver chloride. Alright, so the reaction is listed there, and the very first thing that we need to do is we need to be able to come up with the written reaction, the actual formulas here. So what we have here is we have magnesium, okay, and we looked that up on the periodic table. It's a +2 charge. We have nitrate, which is NO3. From your list of polyatomic ions, that's a 1 negative charge. We're reacting that with silver, Ag. Charge on that is a +1. And chlorine, Cl. Charge on that is a -1. What we get out of that is a magnesium chloride. Magnesium again a +2, chlorine a 1 negative, and lastly silver nitrate. And again, silver being a +1, nitrate being a 1 negative. Alright, so now that we have all the charges, we want to write proper formulas here. So remember, in writing proper formulas, what we can do is we can take the values that they don't add up to 0 and we can bring them down to their respective elements. So let's write the formulas here. So this first formula is going to be Mg, and we want 2 nitrates, so it's NO3 in parentheses 2. That's going to react with silver chloride. It's a 1-to-1 ratio, so that's just AgCl. Next, we're going to have magnesium chloride, and that is again doesn't add up to 0, so we need to switch the numbers there, and the chlorine gets a 2, so MgCl2. And lastly, 1-to-1 ratio adds up to 0, so it's a 1-to-1 ratio, and it's AgNO3. Now we need to balance this. This is going to be balanced here with a 2. Now we have 2 nitrates, and we have 2 nitrates on this side, and we're going to need 2 chlorines. 2 here. Now we have 2 chlorines and 2 chlorines on this side. The silvers also are 2, and the magnesiums are 1 each. Alright, so now that we have the balanced reaction, now we can put that information to work and determine the actual stoichiometry, the actual measurements behind this. Alright, so now to solve this, we're going to set up our dimensional analysis. We're going to start, again, we always start with our known, and what we know is we know that we have 1.5 moles of silver chloride. And what we want to be solving for is we want to be solving for moles of silver nitrate. So, question is how we get from moles of silver chloride to moles of silver nitrate. What we're going to do is, as always with dimensional analysis, the label we want to get rid of goes in the bottom, and the label we want to solve for, the silver nitrate, is going to go on top, so Ag. Then we look back to the original equation here, and what we are looking for is the coefficient written in front of each of these. So there's a 2 written in front of the AgCl, so that means this is going to be a 2. And there is a 2 written in front of the AgNO3, so that means this is going to be a 2. So it's actually a 1-to-1 ratio. So the moles of AgNO3 is 1.5 moles. And that's how you solve that first problem. So now what we're going to do is we're going to go ahead and look at the next problem. So in this next problem we are asked how many grams of silver nitrate are formed from 0.5 moles of silver chloride. So again, just like we did with the previous problem, we start with what we know. So we know that there are 0.5 moles of silver chloride, AgCl. Okay, and the question is how many moles of silver nitrate can we form from, or excuse me, how many grams of silver nitrate was so important in this case. So first step is to get rid of the moles of silver chloride. So we put moles of silver chloride down here. Next we're going to have moles of AgNO3. That's what we're solving for. Then we want to get rid of the moles of AgNO3 because what are we really solving for? We're really solving for grams. And that means up here we want grams of AgNO3. And that is our final answer. So the first thing for what I would recommend you do is you set up the problem before you put any numbers in here. Set up the problem so that you know that all your labels are going to cancel and it's going to give you the answer you want to have. So we know already, we can go back just like we did in the last problem, we can look at the molar ratio. We know that the molar ratio of AgNO3 to AgCl is a 2-to-2 ratio or a 1-to-1 ratio. Now we need to know the moles of AgNO3, or the, we should need to know the molar mass of AgNO3. So 1 mole of AgNO3 has a mass of, and now all we have to do is the math here. And we get an answer of 84.94 grams of AgNO3. So that's how we solve that problem. Let's look at the last problem. The last problem asks how many grams of silver nitrate are formed from 2.25 grams of silver chloride. So again, what we know is we have 2.25 grams of silver chloride. Okay, so that means we want to get rid of grams of silver chloride. And remember, whenever we're doing stoichiometry, or whenever you're looking at ratios of elements, it's always molar ratios. So that means that we want to go to moles of silver chloride. Then from moles of silver chloride, we want to get rid of that, and we want to get to moles of silver nitrate. Moles of silver nitrate up top here. Once we're in moles of silver nitrate, our real answer we want is in grams of silver nitrate. So we get rid of the label that we want to get rid of, or write the label we want to get rid of down below here. Moles of oops, forgot to put the silver in there. So we have moles of AgNO3 and we want it to be in grams of AgNO3. And that's what our final answer is going to be. So now we go ahead and we fill in our chart here, and first thing we need to know is we need to know how many grams 1 mole of silver chloride is. And so 1 mole of silver chloride is going to have a mass of 143.31. And then we know again the ratio, this is based on our balance equation, that it's a 2-to-2 ratio of AgNO3 to AgCl. And then we want to convert back to grams, so we say that 1 mole of the AgNO3 and the molar mass that we had, apologize for the barking in the background of this lab, is 169.87. And once we have all that information, really then it's just some math. So we have 2.25 divided by 143.31. We take that answer, and obviously we're multiplying it by 1, and then we're going to multiply it again by the molar mass of AgNO3, which is 169.87. And I made a mistake there, sorry. And we get an answer of 2.67 grams of AgNO3. So that's how we solve for this. And again, the way you double check that you have everything set up correctly is labels. Can you cancel your labels and leave you with only the label you want? So grams of AgCl or silver chloride cancels grams of silver chloride, moles of silver chloride cancels moles of silver chloride, moles of silver nitrate cancel moles of silver nitrate, and the label we want is grams of the AgNO3, and that's what's here. Alright, I hope this helps out with the homework, and we'll see you in class.